what we've done so far is we've looked at the unit circle in terms of labeling all the degree measurements inside here, all of the radian angle measurements inside here, but those aren't really part of the unit circle. The unit circle is the bold circle that's around the outside, and what we care about are the xy coordinates for each of these points here. So we're going to take this a piece at a time. We're going to first focus on the point that's 30 degrees away from the positive x-axis right there. So whenever you want to find the coordinates of any point, it traces out a triangle, a right triangle. It looks like this, bam, bam, and bam. And now basically in order to find the length or the xy coordinates, I just need, what is this base length of this right triangle? And I need the height of this right triangle. But look at the triangle that's in there. I think there's something special about it. What's this angle measurement down here? Look, it's given to you right here. It's 30 degrees. This would be a right angle. That would be 60 degrees. It's a 30, 60, 90 right triangle. And in order to solve that, you only need one piece of information. Just need one of the side lengths. And which side length do we know? On the unit circle, which of these three segments, or do I know? And obviously, I know the hypotenuse length. The hypotenuse length is the length of the radius, which we know to be 1. So there we go. We have a hypotenuse length of 1. So if the hypotenuse is 1, how big is the shorter leg? It's half as big as that. And then the bottom segment down here, which is the longer leg, it's got to be that times the square root of 3, which gives us a way to figure out what the x, y coordinates of that particular point. It is the square root of 3, 2, 1/2. All right, so we have our first coordinate on our unit circle. Let's label it. So right here at the 2 o'clock mark, let me get rid of my 2 o'clock. I don't actually need it there. This point is the square root of 3 over 2, 1/2. And remember the whole entire reason why this is true. I can think of it in terms of making a 30, 60, 90 right triangle there. And that 30, 60, 90 right triangle, the hypotenuse is 1. And then we've already solved this. I get a half for that side, and for the base, I get the square root of 3. Let's get rid of all this stuff. Okay, so now we're going to see what is the connection between that point and the trigonometry that we've been doing so far this lesson. Let's see what the connection between those two. Okay, so how can this unit circle be used to find the following? We have the cosine of 30, we have the sine of 30, and we have the tangent of 30 degrees. I need some place to write. It's going to be way, way, way down here. Here we go. So in order to find sine, cosine, and tangent as we've defined it, we need a right triangle, which we have. We need an acute angle, and our acute angle is the 30 degrees that's in here. And then we need to label our sides in reference to that 30-degree angle. The 1/2 here is our opposite side. The square root of 3 over 2 is the adjacent side, and then the hypotenuse is 1. Cosine. Cosine is another hour, A over H. So in my right triangle here, my A side is the square root of 3 over 2, and my hypotenuse side is 1. Divide anything by 1 is itself, so it's the same thing as the square root of 3 over 2. Okay, all right. Let's do the same thing with a sine. So the sine, oh hell. Opposite over hypotenuse. Our opposite side is 1/2. Hypotenuse is 1, which of course is the same thing as 1/2. So let me pause right there so you can make a connection. And that connection should be the square root of 3 over 2. Do I see that? Do I see that on my unit circle? Same thing as the x coordinate over here. Okay, and this 1/2. Maybe pink. It's 1/2. Do I see that on my unit circle? Sure. It's this 1/2 that's right there. It's the y coordinate. Boom. Okay, let's continue this problem. The tangent, finally, is supposed to be the opposite over the adjacent. Opposite over adjacent is, my opposite side is 1/2. And my adjacent side is the square root of 3 over 2. I'm going to highlight these the same exact colors because this square root of 3 over 2, that was the wrong color. This 1/2 that's on the top there is the same thing as the 1/2 my y-coordinate. This square root of 3 over 2 is the same thing as the x-coordinate that I have right over here. It's like your y-coordinate over your x-coordinate. Okay, but we don't like to write it like that, leave it like this. This is what's called a complex fraction. We want to simplify it. So let me walk you through that process. I've got a division problem. It is 1/2 divided by the square root of 3 over 2. I'm going to rewrite that old-fashioned style with this division symbol like this, square root of 3 over 2. Because when we divide, when it looks like that, you go, oh yeah, I remember. Divided by a fraction, I'm supposed to multiply by the reciprocal. So I go 1/2 times, and then I flip the second one, 2 over the square root of 3. And then I can cancel the 2's out. And then when I multiply straight across, I get 1 over the square root of 3. But we don't like to write it that way. Instead, let's rationalize it. Square root of 3 over the square root of 3. And I would get square root of 3 on top. And square root of 3 times the square root of 3 is 3. Root 3 over 3. Let's check these in the calculator. Again, these give us exact values. Square root of 3 over 2, 1/2, and the square root of 3 over 3 in the calculator. Let's go. Yeah. That was the cosine of 45. We're going to do that one next, but here, let's do, we had the cosine of 30 degrees. And let's hit enter on this one. You see it's this 0.866 business, decimals that go on and on forever. And then if I hit my little fraction bar and then put in a square root of 3 on the top and I put a 2 down here in the bottom, bam. Oh, that was unhelpful. Bam. And now we can see that those two decimal numbers are identical to each other. So the exact value of the cosine of 30 is the square root of 3 over 2 that we can get easily from the unit circle. Okay, and then if I did the sine of 30, that should just be a half, so it's going to come up as a half, right? Or if you put that into your calculator, usually it comes up as a decimal, 0.5. Okay, let's do the tangent. The tangent of 30 degrees. Tangent of 30 degrees, approximate that. Decimal number, it's this, 0.577. We got, as our exact answer, square root of 3 divided by 3. So let's approximate that one, and we can see that those two things are exactly the same as well. This is why we use it. This is why we love the unit circle. Okay, but, you know, there's more to it than just that point. There's lots of points on there. Let's look at the outer circle once again. This time we're going to concentrate on the 45-degree angle. So on the 45-degree angle, we're going to do the same thing. We're going to zoom in. If I wanted the coordinates of this point, I need to trace out a right triangle. And the bottom of it's going to give me the x-coordinate. The right-hand side is going to give me the y-coordinate. I need to solve that right triangle. Well, I know that it's a 45, 45, 90 right triangle because it goes to this 45-degree angle that's right there. And I just need one piece of information in order to solve that. And the piece of information that I know is the length of the hypotenuse. It's 1. It's the radius. And then, hey, here's the right triangle that we solved at the beginning of this objective. Each one of these is the square root of 2 over 2 for each side, which means that my x-coordinate is the square root of 2 over 2, and my y-coordinate is also the square root of 2 over 2. Let's label it on our unit circle, shall we? Indeed. Where the heck is it? It's way up here. This point. Square root of 2 over 2, comma, square root of 2 over 2. All right? And we'll see how that applies to trigonometry again. Hopefully, you know the same relationship holds true that we saw before. How can the unit circle be used to find the following? The cosine of 45, the sine of 45, and the tangent of 45 degrees. It's around here someplace. It's right here. Okay, cosine Cosine tangent of 45. So as we did before, we'll label our sides. Here's our 45-degree angle. This is our opposite side. This is our adjacent and our hypotenuse. Cosine is adjacent over hypotenuse. My adjacent side is the square root of, put an equal sign in there, square root of 2 over 2 divided by 1, which is the square root of 2 over 2. If I do my sine, it's opposite over hypotenuse. My opposite side is the square root of 2 over 2, and my hypotenuse is 1, so it's just the square root of 2 over 2. Hey, look. That exactly matches up with my x-coordinate. No, I'm guessing I'm going to have to do blue this time. That matches up with my y-coordinate. It's pretty easy to get these things mixed up since they're exactly the same, but the same relationship holds from that 30, 60, 90 triangle that we looked at before. Okay, and then this last one for tangent should be opposite over adjacent, opposite root 2 over 2, adjacent root 2 over 2. Anything divided by itself is 1. Tangent is just equal to 1. Tangent of 45 degrees is equal to 1. And again, let's go ahead, put these things into the calculator. So if I were to put in, let's start with the tangent, because the tangent of 45 is supposed to just be 1. Bam, there it is. And if I do the cosine of 45 degrees and approximate this one, we get that 0.707 business, which should be the same thing as the square root of 2 divided by 2. And indeed it is. And the sine of 45 should be the same thing, but watch this magic happen here on this calculator. Bam, it just tells me, with that computer algebra system, gives me the exact answer. Don't be jealous. Anyway, all right, let's do one last little thing to wrap this one up, and that is to formally then define the sine, the cosine, and tangent. We define sine, cosine, tangent in terms of right triangles, but its full definition has nothing to do with right triangles. Right triangles just give us a way to visualize what's happening with sine, cosine, and tangent. Sine, cosine, and tangent are based on points on the unit circle, where the x-coordinate is the same thing as the cosine of your angle. The y-coordinate of any point that's on the unit circle is the same thing as the sine of the angle. And then finally, to find the tangent, we're going to take the y-coordinate divided by the x-coordinate. I would suggest on your unit circle just writing these definitions. And we're going to play around with them in a little bit more detail in the next video.